6A is all about trapezoids, and then we're going to talk about kites for 6B. So two different types of figures here. But the trapezoid, that first is just the definition. So it's a quadrilateral. Quadrilateral means what? Four sides, okay? Quadrilateral with exactly, keyword, exactly, can't have any more, can't have any less. One pair of what? Not congruent, parallel, right? So a quadrilateral with exactly one pair of parallel sides, okay? So here's the different parts that you'll see. The two that aren't parallel are called your legs. And then your parallel sides are called your bases, okay? So this is a base, and this is a base. Then with that, there are what are called base angles, and technically everything is a base angle, but you have to associate them with a particular other angle. So the two that are on the same base are base angles together. So like this angle and this angle, those are base angles, okay? But I could also say that this angle and this angle are base angles, okay? So when we talk about base angles, we're talking about the two angles that lie on the same base, the same parallel line, okay? So those are base angles. Then if you look just to the right of that, that triangle there has legs that are congruent. Not triangle, trapezoid, sorry. Any guesses what we call that? No. No. But if you think English, that was a good guess because it started with an E, right? Because I put the word "an" in there. Isosceles. So this is called an isosceles trapezoid. Okay, and an isosceles trapezoid is going to have congruent legs. And just keep in mind your legs cannot be your bases. So you'll have parallel sides, and then the other two sides are the ones that are congruent. Okay? So that's trapezoids. There is a theorem that goes along with an isosceles trapezoid. That says this: if a quadrilateral is an isosceles trapezoid, then each pair of base angles is what? Congruent. Okay, so if this is an isosceles trapezoid, what that means is the two angles that lie on the same base are the same. So that means this angle is the same as this angle, and this base angle is the same as that base angle. Okay, what do you know about these two angles? Right, they're going to add up to 180. They're supplementary because you have parallel lines, right? So supplementary, just like just like for a parallelogram, okay? This is not a parallelogram, but same idea. Matthew, I'm assuming you're in the notes right there? Yeah, okay. Yeah, that's fine. Just making sure. All right, so let's look at the first example. It says RSTU is an isosceles trapezoid, and the measure of angle S is 75. Okay, so this is a 75-degree angle right here. What would the measures of the other three angles be then? Can you tell me one? Daniel.
Angle T would be 80 and 95.
No.
Because it
Has to add up to what? 180.
100.
Right, so these two have to add up to 180. So you're going to say 75 plus, we'll call this X right now, equals 180. So if you take away that 75, then that X is going to be 105. So this angle down here, I'm going to take X away now, would be 105. Okay? What's U?
105.
That's 105. Those are base angles, right? And it's isosceles, so base angles are always going to be the same in an isosceles. What's angle R? 75. Okay, so in an isosceles trapezoid, you're only going to have two different measures, all right? Any questions on that? All right. Moving on. Oh, quick asterisk here. If RSTU wasn't isosceles, would R and U or S and T still add up to 180?
Yes.
Why?
Because of the transversal.
Right. You have parallel lines, right? With that transversal, those are same side interiors. So regardless of isosceles or not, these are still going to be same side interior angles. So the answer to that is yes. You will always have the two angles that touch different bases, okay? Those will always be supplementary, okay? All right, let's look at example 2 here then. This one says, what are the values of x and y in the isosceles triangle below if DE is parallel to BC? So here's DE, here's BC. They're telling us if those are parallel, what would our missing angles be here? What do you need to do with that? Keeping in mind, they told us that the triangle is isosceles. So what is that telling us? If we have an isosceles triangle for this, right, this triangle here is isosceles. What do we know? Daniel.
Well, we know that 32, 180 minus 32 divided by 2 is equivalent to y, and then we can do 180 minus
Right.
y is
So
x.
because we know it's isosceles, we know these two angles are the same. So we can call this y right now. If we're just looking at the triangle, forget DE for a second, okay? We know that 32 plus y has to equal 180 because that makes a triangle. So if we take away that 32, then we get 2y equals, what is that, 138? 148. 148. Mental math. So divide by 2, and we get that y is 74. Okay, so I know that this angle here and this angle here are both 74. Okay, now look at this. What is that?
It's
It's an isosceles trapezoid. Because you had the isosceles triangle and you have that parallel line, that's going to be an isosceles trapezoid. And in an isosceles trapezoid, actually, it doesn't even matter. Maybe it isn't isosceles. I mean, it is. But even if it wasn't isosceles, how do you find x right now?
you subtract it from 180.
Right. So we know that these two have to add up to 180. Okay, those are supplementary. So we would say x plus 74 is going to equal 180 degrees. So take away that 74, and you get x equals 106 degrees. So that would be both of those angles here, 106 and 106. Okay? Questions on that? All right, let's look at this next theorem then. Am I going too fast?
No.
Yes? Who said yes? No? All right. Theorem 620, you don't need to memorize the number, it's just a way for me to label it. Says if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. So in this picture, this is an isosceles trapezoid. What they're saying is TR is congruent to US. Okay? Now think about what that means. If the diagonals are congruent and it is isosceles, okay, that means everything's pretty mirrored. what ends up happening is this. You have two isosceles triangles, not four. Okay, with the rectangle, you had 4 isosceles triangles, right? It broke it all into pretty parts. With this one, you would have this piece congruent to this piece, and this piece congruent to that piece. So you have an isosceles triangle here, right? That would be an isosceles triangle. You also have an isosceles triangle here. But notice they're not the same isosceles triangle. In a rectangle, they're the same triangle, right? In an isosceles trapezoid, they are not. So just be aware of that. You do have some things about them that are the same. For instance, I would say that this angle here is the same as the angle up here, right? And that's the same as this angle, which is the same as that angle. So you do have some angles that match up, but your side lengths don't match up. So the triangles themselves are not the same, okay? You could also say this being vertical angles, those are congruent, or these vertical angles are congruent. These angles up here, sorry, we're getting into a lot of arcs. Right? And then even these ones down here are also the same. I'm not going to do 5 arcs, but you have a lot of congruent angles in there. Notice that these 2 triangles on the sides are the same triangle. They're just not isosceles triangles, right? So I could flip that one over and it would be the same triangle, just not isosceles. Yeah?
How are S, T, R, and S, U, R?
So if this is truly an isosceles triangle, then, which it is, we said that, right? Then this angle, this whole thing, and this whole thing are the same, right?
Oh, yeah.
The big angle. So then if I know that those 2 smaller angles are the same, then the bigger ones would have to be the same also. That's angle addition postulate. Does that make sense? Any other questions on that one? It's a whole lot of angles that match up, right? The good news is it's very symmetrical. So if you're not sure, you can probably just think, if I folded this in half, what would match up? Okay. All right, last little tidbit here then is called the Trapezoid Mid-Segment Theorem. There's 2 parts to this, okay? When you have a trapezoid, we talked about this with a triangle. Remember the triangle mid-segment theorem where you had a triangle.
Staff and students, please excuse this interruption.
Okay, so triangle mid-segment theorem. When we did this one a few weeks back, we said if you have x here, then what is this side going to be? 2x, right? The one is half the length of the other. This would be 2x. Okay, so trapezoid mid-segment theorem is very similar. Oh, and the other thing was these were parallel, right? Okay, so trapezoid mid-segment does the same thing. The first thing is the mid-segment, so here's your mid-segment, it is parallel to both of your bases. Okay, so we know that all 3 of those are parallel to each other. But then the second thing says the length of the mid-segment, so the red line, is half the sum of the lengths of the 2 bases. Okay, so if I call this, let's just give these letters for now, A, B, C, D, E, and F. Thank you, Mrs. Bacher. I'll take it. She can grab it. Thank you. Oh, this is Matthew's. Oh, we got 2 of them today. Thank you. All right, so with this setup, what it's saying is, first of all, that AB is parallel to FC, and ED is parallel to FC. Okay, so that's the first part of the theorem. But the second part of the theorem is saying the relationship between them. And there's 2 ways you can think about this, okay? You can either double the mid-segment. This is not the way the theorem's worded, but I feel like this is the way people end up doing it a lot of the time. So I'm going to write it both ways for you. You don't have to do both. It's one or the other, okay? You can either double FC, and it will equal AB plus ED, okay? Or you could take FC, and it will be half of the sum of the two bases, so AB plus ED, okay? Notice those are really saying the same thing. If I were to multiply both sides by 2 on that bottom one, it would look like the top one, okay? So I don't care which one you use. It's whatever makes more sense to you. Another way maybe to make it a little easier on you is if you called this X, Y, and Z, you could say that Y equals half of X plus Z. So if that just simplifies it for you a little bit, that's fine. You can look at it like that too. Okay. Yeah.
Does that only happen on isosceles trapezoids?
No, it can happen on any trapezoid. It just has to be that these two are the same and these two are the same, right? So this could be like, say this is 4 and 4, and this is 3 and 3, right? So that's not isosceles. It just has to be that the parts are the same and the parts are the same. Just like with triangle mid-segment. Didn't have to be an isosceles triangle, but it had to be that the mid-segment broke that triangle into equal distances for the transversal. Okay? That's a good question. Okay, so let's look at example 3 here. It asks, what is the value of X? So notice we have a mid-segment because they marked our sides congruent here and they marked our sides congruent here. So this is a mid-segment. Okay, how could I set this up? What's one way you could set it up? Right. Right, so you could double the X plus 2. Where you have to be careful with that is make sure that you put the parentheses around because you have to distribute that to both, okay? So 2 times X plus 2 would equal 4X minus 10 plus 8. Okay, so that's one way you could set it up. What's the other way you could set it up? Yeah, Daniel.
X plus 2 is 1/2 4x minus 10 plus 8.
Right. Okay, so those are both correct, and they're both going to get you to the same answer. It's up to you which one you prefer to do, okay? I feel like most people prefer this one just because they don't like fractions very much, but you can do either one. So if we distribute this, you get 2x plus 4 equals 4x minus 2. So then take away the 2x and add the 2, and you end up with 6 equals 2x, and then just divide by 2. Okay, so x is 3 in that case. Here's the thing with this. You can always plug that back in, and let me just show you what will always happen here. If you plug it back in, okay, so I plug in a 3 here and a 3 here. 3 plus 2 is 5, so the length of the mid-segment is 5. The length of this one is 8. The difference between those is 3 units, right? That means the distance between these needs to be 3 units also. So you could always figure it out that way as well. 4 times 3 is 12. 12 minus 10 is 2. And between 2 and 5 is 3 units. So you can always double check it just to make sure that they are evenly spaced, and then you know you got the right answer. Okay? Any questions on that? All right.